All right, today is a short course in multiplying vectors. When you multiply vectors, we have the exact same problem we had when you were trying to add vectors. Adding scalars is easy, you just add them together. Multiplying, also easy, you just multiply. But with vectors, the direction has to be taken into account. So how do we do that? Well, there are two ways, actually, to multiply vectors. There's what we call dot products and cross products. And in principle, it's really simple. Dot products, you get a scalar, and the magnitude of that scalar is just a times b times the cosine of the angle between them. Cross products actually produce a vector quantity, and the magnitude of that vector is a times b times the sine of the angle theta, right? Where theta is, again, the angle between the vector a and b. Now, the obvious question is, why would you do that? Why ab cosine theta and ab sine theta particularly? Well, the idea is that dot products are going to multiply the parallel parts of the vector, and cross products are going to multiply the perpendicular parts of the vector. So picture this. Here's a, here's b, here's theta. B can be broken down into two equivalent blue vectors, right? We go up this way and then down that way, and this is a right angle. So you break that into pieces, that's a right triangle, and by the rules of trigonometry, since this is the adjacent side, the length of this side is going to be b cosine theta, and since that's the opposite side, the length of that side is going to be b sine theta. So to say a times b cosine theta is to say you're multiplying a times just the parallel part of b. And if you say ab sine theta, that means you're multiplying a times just the perpendicular part of b. Okay? But that still doesn't really answer the question why. I'm getting there. The two examples that we're going to use to illustrate this is pulling a sled and turning a wrench. When you pull a sled, you do work, and we'll talk more about that in the next unit. When you turn a wrench, you apply torque to the wrench, and those are calculated as dot products and cross products respectively. So you multiply the force that you pull the sled times the distance that you pull the sled, and that will tell you how much work that you did. But it's a dot product because clearly any force perpendicular to the ground is not going to help you slide the sled. So we only count the part of the force that's parallel to the ground, and the perpendicular part gets ignored. Thus, we do a dot product for work. Now, equally obviously, when you turn a wrench, the size of the force matters, and the length of the wrench matters, because the longer the wrench you have, the more leverage you get. So you're going to multiply those together to figure out how much torque you get. But keep in mind, the best way to turn a wrench is to put your arm perpendicular to the wrench. But let's say the wrench is in an awkward position, so you can't reach to do that. So you pull at some awkward angle. Some of your force is going to be parallel to the wrench and will not help you turn the wrench. Only the perpendicular piece of the force matters for turning the wrench. And thus, we do a cross product to figure that out. So, try it for yourself. Suppose the force in both of these cases is 200 newtons, the angle in both cases is 30 degrees, and the displacement is half a meter. I want you to calculate the work in this case and the torque in that case. And that's it.